The next entry in the Edit Mode toolbar is the Poly Build tool. To demonstrate its use, we'll start by creating a plane and then enter Edit Mode. With the Poly Build tool selected, we'll see any edge that we move the mouse pointer near turn blue. And if we hold down the left mouse button and drag, we'll add a new face to our mesh. If we drag on a vertex, it moves to a new location. But be aware that the face may no longer be coplanar. During the drag operation, in the top left of the viewport, we'll see the distance moved by the existing vertex or new edge in each of the 3 dimensions. If we press the Control key when an edge is showing blue, we'll add a new vertex at that point, and dragging creates a new tri-face. We need to release the Control key as we drag the vertex. Otherwise, the current snapping setting will temporarily be inverted. Since snapping is likely to be off, this will switch it on until the Control key is released. If we want a more permanent change to the snapping setting, pressing the combination Shift-Tab will toggle snapping. We can see the snapping icon switch state each time we press this combination. When we use the Control key and drag combination on a tri-face rather than create a new face, Blender changes the tri into a quad. But be aware that the 2 parts of the new face may not lie on the same plane. This action of converting tris to quads is controlled by the Create Quads checkbox shown in the top left of the 3D viewport. If we uncheck this option, Blender will no longer convert tris to quads. If we hold down the Shift key and move over a vertex, clicking will delete the vertex. Holding down Shift and moving over an edge or face will outline the face in red, and then clicking will delete the whole face. As you can see, as we add more rather random faces to our structure, the overall effect looks somewhat disorganized. One way to better control the shape is to work in a named viewpoint, such as top. This will restrict the new face to movement in 2 dimensions only. Although working from a named viewpoint creates a more controlled shape, it does limit us to 2 dimensions, and we have to change to a different named viewpoint to extend in the 3rd dimension. An alternative to all this is to make use of the direction letters using the X, Y, or Z keys when dragging out a new face. This will force the face to extend in the specified direction. If we hold down the Shift key and then press a direction letter, the new face can move in the remaining 2 dimensions. For example, pressing Shift-Z would allow the new plane to be moved in the X and Y directions only. If you can manage the rather awkward combination of holding down both the left and middle mouse buttons, the new face created by extending an edge will be forced along a specific axis. And the combination Shift plus the left and middle mouse buttons force the extrusion along a specific plane. When we use snapping, which we can do by either holding down the Control key or actually switching on the snapping option, the type of snapping we get depends on the settings in the snapping panel. By default, this is set to Increment, which effectively creates movement in discrete steps. But if we were to change this to, say, Vertex, snapping would cause the positioning to jump to any nearby vertex. Another useful tip is to switch on automatic merging for vertices which are close to each other. This allows us to merge vertices when one vertex is placed over some other existing vertex. For example, if we switch on the statistics display, we'll see in this example that there are 29 vertices in the mesh. But when we snap the vertex being moved to a second vertex, they merge and the vertex count is reduced to 28. If we press the B key while dragging an edge, Blender will allow us to select part of that edge to snap to some other element, usually part of a separate mesh. Exactly which part of the edge that can be selected and which parts of the target area that can be snapped to depends on the settings in the snapping panel. Let's watch that again. We start the drag as usual. Then press the B key. This causes the edge we are moving to jump back to its original position. With the left mouse button still held down, we'll see the snapping positions highlighted with their appropriate symbols. A square for a vertex, triangle for the center of the edge, and an hourglass shape for the other parts of the edge. Next, we release the mouse over the element of the edge to be used for the snapping operation. And with no mouse buttons pressed, we move to the destination location. Again, we'll see the snapping positions here highlighted, and left-clicking completes the move. When dragging a vertex, holding down the G key will slide the vertex along existing edges. With an edge selected, pressing R allows us to rotate that edge, but this will make the existing face attached to that edge non-planar. When we are creating a face by extending an edge, pressing S allows us to scale the size of that edge. The Polybuild tool also creates a last op panel. Here, the first entry is a Flip Normals checkbox. This is used to reverse, which is the front and back faces of our newly created face. To demonstrate, we'll start by switching on face orientation in the Viewport Overlays panel and flip the normals of the newly created face. The Move fields allow us to adjust the position of the new face's leading edge. Orientation specifies which set of axes the Move fields reference. Mirror editing can be ignored at this time. Finally, checking proportional editing will switch on proportional editing, a topic we covered in video 23, and adds more fields to the last op panel. The Polybuild tool is often used extensively in retopology, which, put briefly, involves simplifying the complexity of an existing mesh. But this is a topic for a future video.